So record করে নি, তোমরাও চাইলে রেকর্ড করতে পারো। So last time we studied travel time, and there is one more component remaining from the last lecture, that is delay study. So we will be focusing on delay study today, and after finishing delay study we will actually today we have around 2.5 topics to cover. First one is delay study, then we will learn about crash study or accident study, and then we will start parking. We will calculate parking demand, and there we will stop. And then in the next lecture we will be finishing the parking study and starting the traffic signal design. And after that, on the 14th week, we will just finish the finish the signal designing, and with that the course will finish. The way I design it is always like 14 weeks. 15 weeks is not really an international standard, so everything will be finished by 14 weeks. 15th week, the other professor involved in this course, Ibrahim, he will come, and if you have any problems, any concerns, or whatever it is, then you discuss with him on that week. I will not be in Bangladesh on hopefully on the 15th week. So, and after that there will be the exam. So we have already finished travel time study. So today we will be starting with delay. So what is delay? Delay is a portion of the total travel time that is particularly not liked by the traveler. So when you are traveling, you actually don't find it bothering. But whenever you are traveling and you have to stop, then you actually feel annoyance, and that is the part that is called delay. And delay actually has very high importance in transportation planning, because many times if you say, for example, if you want to go from A to B using route 1, maybe the route 1 takes 40 minutes, and there is route 2. Route 2 takes 30 minutes, but in case of route 1, you actually don't have to stop. You can go very smoothly. In case of route 2, it takes around 30 minutes, but maybe the actual travel time is like 10 minutes, and 20 minutes is actually spent on delay. Many times you will see people traveling using route 1, because that is actually giving them an uninterrupted travel. Even in my case, like I have seen, like now to travel from IoT to Uttara has become better. But previously, when the construction works were going on, many times I used to take the route through Kamarpara, then come to Uttara sector 10, and with that way I used to come up to the airport. But I knew that's like a long detour. But the good thing was, like, at least the vehicle stops at fewer places. But in the straight section, like, it was always like stop and go, stop and go. So delay is the annoying part of the travel time. So delay along an arterial might include stopped time due to signal, mid-block obstruction, or other causes of congestion. If the traffic is very high, then automatically you will have delay. If there is an obstruction in the mid block, say for example parking or something else, then you can have delay. Or if there is a signal, or if there is an intersection where you have a stop control, actually you have to stop, and then you will be having some delay. So at signalized and stop control intersections, delay takes on more importance, as travel time is difficult to define for a point location. So in general, when we do the travel time study, as you have seen, it's for the network or for a long corridor. Delay is actually a specific point. So that is why it is very important, like, to identify the points on which we are losing a lot of time. So In case of intersection delay, the other kinds of delays actually are easier to solve or very difficult to solve. Say, for example, if you have very high demand and the delay is because of that, the solution is not easy. You have to do a massive investment for that. Or if it is because of illegal parking or something like that, you can easily solve it. But there is one delay which definitely you can do something about, and that is called intersection delay. Be it because of there is a stop sign or be it because there is a signal. But intersection delay, when we talk about intersection delay, there are many different definitions. In old ages, we used to use one definition. These days, we are using some other definitions. So let's go through all those delay definitions. The first one is stopped time delay. This is actually the most common one that used to be used say like 2-3 decades back, and it is the easiest to calculate. You just calculate the amount of time the vehicles are remaining completely standstill because of intersection has signal or intersection has a stop sign. But these days we don't really use this one, but this is the easiest to measure. Then approach delay. With the stopped time, you also add the delay due to deceleration and delay due to acceleration, because like when you are seeing that you are approaching a signal, you start decelerating. So you are not traveling at your desired speed. So you are losing some time there. And then when you are crossing the intersection from stopped condition, you have to accelerate. So again, you will be losing some time because otherwise you could have just gone that distance at your desired speed. So these two delays get added with the stop time. Then we get the approach delay. Time in queue delay is actually more comprehensive. So it also calculates how much time did you spend on the queue plus your stopped time. So you are calculating like how much time I am spending in the queue, because like in the stop time delay, you are just calculating because of the signal how many seconds or minutes you have stopped. But here it can happen that you are actually in a queue, and then the signal becomes green, but you cannot even cross it. You are again on a queue. So it calculates the total time you are in the queue plus how much time did you spend because of that stop control. And this is a bit more comprehensive than the approach delay. Actually, approach delay doesn't really consider about the queue thing. And the final one, which is like the control delay, is actually the one that we use these days. It will measure the time that you have remained completely standstill because of seeing the red light, plus the time that you have spent in the queue, plus the time that you have lost because you had to decelerate, plus the time that you lost because from standstill you had to accelerate. So all those things are getting added up in control delay, and highway capacity manual now suggests us to use this one as the measure of delay. But as you can understand, this is not going to be easy to calculate this delay, and we will see how we can do it. Every time the way we start is like, first we learn the definition, then we learn why we need it. I think we have covered all these 2 points. The third thing is how do we design the survey to actually collect this data, and the fourth one is how we analyze and interpret the result. So let's move on to the remaining 2 parts. That was intersection delay, and now we also have delay along the route that I have just told, which is like easier to resolve. It is the difference between the actual travel time traversing a section of highway and the driver's expected or desired travel time. So if there is no traffic, if you directly drive, then how many minutes do you need? And then when there is traffic, how many minutes do you need? The difference is actually your travel time delay along the route. So along the route, actually there can be intersections. So you have to calculate the intersection delay and the delay not caused by intersection separately. And when you add all those things together, you actually get the delay along the route. And you also have it recorded because you have the overall travel time, right, to traverse that section. So normally delay calculations methodology is loosely defined. When we are collecting data, except for intersection data, when we are collecting data for travel time study, from that we actually can gather the information regarding delay as well. And it is seldom used for assessing congestion along a highway segment. Some types of delays are measured as part of travel time study, as we have explained before, by noting the location and duration of stop periods during a test run. So then we can clearly understand where are the locations we are losing time and how much time are we losing. While speeds are generally studied at a point under consideration of free flow, travel time and delay are generally studied along sections of roadway under congested condition. We have also discussed this issue during our last lecture. When you are calculating delay along the route, before 1997, stopped delay used to be the most preferred measure. But as I have told you, last 3 decades, we are not using it anymore, at least in the situation when we have more information. Now, total control delay, which is defined as the time in queue delay plus time lost due to deceleration from and acceleration to the ambient speed, that is these days used, recommended by the highway capacity manual. And total control delay methodology is based on direct observation of vehicle in queue at frequent intervals and requires a minimum 2 observers. And we will see how we can distribute the responsibilities of these 2 observers. So before we move into how to collect data or design survey for intersection delay calculation, we need to know one more term that is called saturation flow rate. Why we need to learn this term? Because intersection delay methodology that we will study now can only be applied when the intersection has not reached its saturation flow rate. When it's lower than that, we can do this study. If it is at that level, we cannot do this study anymore. Saturation flow rate is just like more like the capacity kind of thing. So like when there is no control in an intersection and you have very high volume operating there, the maximum number of vehicles that can pass that intersection, that is actually your saturation flow rate. And normally when the intersection reaches saturation rate, flow rate, we actually don't do delay study anymore. It has to be done before that. So some important points intended for when we are calculating the total control delay, important points are it is intended for unsaturated flow condition and for cases where maximum queue is about 20 to 25 vehicles. If you have a queue over 20 to 25 vehicle length, then again you cannot do this intersection delay study. It means that the intersection is already in bad shape. The method does not directly measure acceleration and deceleration, but we have to measure acceleration and deceleration, right? So you will see there are some empirical charts, some terminologies that we multiply with the value that we have calculated, or we add some extra values to it. That's the way we actually accommodate the acceleration and deceleration delay. And we also need to know the free flow speed at the beginning of the detailed survey. And how you can do it? You can just drive through that intersection, assuming that during the condition when you have like green signal and the traffic is not that much, or if it is a stop control, then you find a space when there is no vehicle in the intersection, you just drive through. So that is your free flow speed, and you have to take that data because you will see we will use that data in the calculation of the total control delay. Now, before we move forward, do you have any questions? তোমাদের কি কারো কোনো প্রশ্ন আছে? ডিলে কাকে বলে? কয়টা সংজ্ঞা এখানে আছে? ডিলে স্টাডিটা কেন ইউজ হয়? এবং কোন কোন সিচুয়েশনে এটা ইউজ করা যাবে এবং কোন কোন সিচুয়েশনে এই স্টাডি করা যাবে না, এইটুক পর্যন্ত আমরা এখন পর্যন্ত পড়ছি। এটুক কি তোমরা পুরোপুরি বুঝতে পারছো? এটুক কি পুরোপুরি বোঝা গেছে?
জি স্যার।
ওকে, ফাইন। আজকে লোক সংখ্যা এত কম কেন? অনেক কম। এনিওয়ে, অনলাইনে এটাই সমস্যা, অফলাইনেও সমস্যা হতে পারে। সো দ্য ইন্টারসেকশন ডিলে স্টাডি, first important thing is the form. So you can see the analyst name, agency or company name, date performed, analysis time period, from what time to what time you have done it, analysis year, area type, whether it's a central business district or other, intersection name, number of lanes in the intersection. Actually, it's good if you add a diagram of that intersection. Then survey count interval, like every X seconds you enter the data. So you remember for our traffic volume count, it was like every 5 minutes or 15 minutes kind of thing. So here also you write it down. Normally it's in second. Cycle length. Cycle length is from one red to another red. How much time do we allocate? That is called cycle length. Stopped vehicle count. So here, how many vehicles have stopped? If it stops multiple times, you count it only one time. So how many vehicle has encountered this intersection and stopped at least once? That's the V stop. And then VT is how many vehicles have arrived so far in the intersection. And now we have the clock time. Clock time is, say, for example, 8:30, 8:31, 8:32, something like that. And cycle number is like one red to another red. It was maybe one cycle can be spanned on several minutes. Okay, so the cycle numbers, you write it down, and even those cycle numbers, you divide it into smaller parts. So like every 10 seconds or 15 seconds. Normally it should be a whole number multiplier of the cycle number. So if you divide, say like cycle time is 60, you can use 10, 12, 15, 20, because you can divide 60 with that number and you get a whole number. So that's the way the count intervals are calculated. So did you understand this chart? So like now we will
সাইকেল নাম্বারটা একবার একটু বলবেন?
সাইকেল নাম্বারটা হলো, তোমার ধরো রেড শুরু হলো, আরেকটা রেড শুরু হওয়ার আগ পর্যন্ত যতটুক টাইম, মানে রেডের পর কি হবে, রেডের পর তোমার গ্রিন হয়ে যাবে, তারপর হলুদ হয়ে আবার রেড হবে।
ইয়েলো।
হ্যাঁ,
জি
তো
স্যার।
এই টোটাল টাইমটাকে বলা হয় সাইকেল নাম্বার, মানে সাইকেল লেংথ, একটা সাইকেল লেংথ।
সাইকেল লেন্থ ওইটা। জি
হ্যাঁ,
স্যার। আর
সো
নাম্বারে?
নাম্বার হলো প্রথম সাইকেল নাম্বার, দ্বিতীয় সাইকেল নাম্বার, তৃতীয় সাইকেল
ও
নাম্বার।
আচ্ছা,
ধরো
বুঝতে
8টার থেকে
বুঝতে
শুরু করলা,
পেরেছি।
প্রথম সাইকেল, হ্যাঁ, তারপর দ্বিতীয় সাইকেল, তৃতীয় সাইকেল, এইভাবে আর কি। হ্যাঁ, সো সাইকেল লেংথ ডি হলো গিয়ে ওইভাবে লিখবা, আর সাইকেল নাম্বার হলো কত নাম্বার সাইকেলে তুমি এই ক্যালকুলেশনটা করছো। নর্মালি একটা সাইকেল নাম্বারে এই পুরা ইটা তুমি ভরে ফেলবা আর কি। ধরো 60 সেকেন্ড হলো, এখানে যদি 10টা দাও, তার মানে হলো এক একটা কাউন্ট ইন্টারভেল হলো গিয়ে তোমার 6 সেকেন্ড, মানে আইএস হলো গিয়ে 6। তো এখন এই চার্টটা সবকিছু বুঝতে পারছো?
জি স্যার।
Okay, so the actual measurements start at the beginning of the red phase of the subject lane group. So whichever lane you are considering, when the red starts, we start counting. And there should be no overflow queue from previous green phase when measurement starts. So when you start the study, you should not have any vehicle in the intersection which came from the previous cycle. So these are the two conditions that we have to fulfill. And now, rather than explaining the observer 1 and observer 2, let's go to this chart first, then we will come back. So here you can see the clock time 5:51. So maybe the cycle time was 60 seconds. Okay, so the cycle numbers are there and we have divided it into 20 seconds. So in the first 20 seconds, number of vehicle in queue, how many vehicles were there in the queue in the first 20 seconds, then second 20 seconds, third 20 seconds. So we write it down. This is the way why we have these columns, because this helps us collect the data. Actually, if we could have done like summing everything at one time for 1 minute, it would have been fine for the analysis purpose. But this is for ease of data collection. Sometimes you cannot remember like how many, if it is like more than 20 seconds or something like that. Okay. So now you calculate VIQ. So this is the total number of vehicles that came in the queue. And here, if some vehicles get repeated, like it was in the first queue, then it was in the second queue as well, doesn't matter. You calculate them all. So actually here you see this column is 40, this column is 50, this is 42. You add all these things up, you get summation of VIQ. VT is always going to be if most of the vehicles are stopping at the intersection, then you will see VT is going to be less than VIQ. So VT is actually the total number of vehicles that are arriving in the intersection. So you can say actually it is possible. Maybe in the red time, no vehicles are arriving. Vehicles are arriving only in the green time. So there is actually no vehicle in queue, but VT is high. It is also possible. V stop is actually how many vehicles have stopped at least once. If a vehicle stops 2 times, you still count it as 1. And FFS is free flow speed. So you already know how to calculate free flow speed. So did you understand how to fill up this chart? So now,
Sir,
bolo.
when VT will be less than VIQ?
VT can be less than VIQ in congested situation when you have a lot of vehicles standing in the queue, and particularly when your signal cycle is not being able to clear up your queue. Then actually VT can be smaller than VIQ, summation of VIQ, as you can see in this example. Okay. So
Yes,
now, collecting the data. Normally, we have 2 people to do the data collection. So you see, observer 1. Observer 1 will actually be whenever the signal becomes red and vehicles start queuing up, this is the person who will actually be calculating how many vehicles are actually in your queue. And the interval should be a whole number integer divisor of the total cycle length. And how do someone understand? And this guy also should be able to understand when the vehicle is like in stopped condition. For through vehicles, exiting the intersection occurs when the rear wheel crosses the stop line. And in case of turning vehicle, actually for turning vehicle, when it completely turns and crosses the pedestrian walkway or something like that, after that actually you can say like it has crossed the intersection. Okay. And at the end of the survey period, vehicle in queue count continue until all vehicles that entered the queue during the survey period have exited. So you should continue the study till there is no vehicle left in the queue. And observer 2, they separately keeps on counting the number of vehicles that are arriving and the total number of stopped vehicles. Okay, so these are the works of the observer 2. So sometimes you may need more than one observer in doing the observer 1's work. Observer 2, it should be fairly simple for one person. And now you fill it up this way. Now, how to calculate the average time, so total intersection delay? First, you calculate average time in queue. So TQ is measured as IS. IS you already know, the count interval. Here, if it is 1 minute and 10 divisions, so it's 6 seconds. In our case, it is like 20 seconds. Okay. Summation of VIQ, you already know, VT you know, and you multiply it with 0.9. Why do we multiply it with 0.9? Because in many cases we have seen VIQ value becomes very big and we actually overestimate the time that someone spends in the queue. So that's why we multiply it with 0.9. So you can calculate TQ from this one. But then we need to calculate two more things. One is called VSLC, which is the number of vehicles stopped per lane per cycle length. So NC is total number of cycles. In this place, we have 10 cycles. So NC is 10. NL is number of lanes. You will know it, whether you have 2 lanes or 3 lanes or 1 lane, something like that. And V stop is the total number of vehicles that stopped at least once. But if it stops multiple times, we still count it as one. So from that, we can easily calculate VSLC. And FVS is actually fraction of vehicles stopping stopping other variables as previous stopping. So it's like total VT is like total number of vehicles that have arrived, and V stop is total number of vehicles that have at least stopped once. So we get the fraction of vehicles that actually will have to stop. And using that, if you know the free flow speed and vehicle stopping per lane per cycle, you can actually get a number like this. And you will see how we use it for the calculation of the total delay. Now, this is the correction factor. We call it the CF, correction factor. The total control delay is TQ that we have calculated, then FVS that we have calculated from here, and we take this value, we come to this chart, we know the free flow speed and we get a value, and then from that we actually calculate the CF, and this is the way we calculate the total control delay at an intersection. So is it clear to you? Clear? Delay কিভাবে ক্যালকুলেট করে ইন্টারসেকশনে? কারো কোনো প্রশ্ন আছে এটার ব্যাপারে?
স্যার, কারেকশন ফ্যাক্টরটা কেন ইউজ করা হয়?
কারেকশন ফ্যাক্টরটা ইউজ করা হয় কারণ ওই যে এক্সিলারেশন আর ডিসিলারেশনের কারণে কতটুকু লস হচ্ছে সেটা যে আমি বুঝতে পারতেছি না। আমার তো কতক্ষণ সময় আমি বসে রইলাম সিগন্যালের কারণে এবং কিউ এর কারণে, সেটা তো আমি ক্যালকুলেট করলাম টি কিউ দিয়ে, কিন্তু এক্সিলারেশন আর ডিসিলারেশন দিলে সেটার জন্য সেটা অ্যাড করতে হবে না। আমি তো এক্সিলারেশন ডিসিলারেশন দিলে মাপি নাই, এই কারেকশন ফ্যাক্টর আর এফভিএস এই দুটা মাল্টিপ্লাই করে সেটা বের করা হয়। বুঝা গেছে?
জি স্যার।
So now we will move to the next part. Which is our crash and parking study. Actually, we can take a 5-minute break, and after 5 minutes, we'll come back again and start the crash study. And after we finish crash study, we'll start the parking study. So just take a 5 minutes break and coming back again. Okay, so we are back with crash and parking study. শোনা যাচ্ছে?
জি স্যার।
Okay, fine. So, whenever we are thinking about crash studies and statistics, normally we have two approaches. There are two major guidelines. One is called ITE, Traffic Safety Toolbox. Another one is called Safer Roads, a guide to road safety engineering. And these two guidelines give us some directions, like in which way we can actually reduce number of crashes, because like whenever crashes are there, we cannot accept people dying or people getting injured which are having long-term impact. And whenever there is a crash, actually a lot of property gets damaged as well, and the infrastructure remain blocked, so the traffic operation gets hampered as well. So we want to avoid crashes. So ITE, Traffic Safety Toolbox, tells us that we can we can have three targets. One is exposure control. If you are not exposed to roads, then actually what is happening is like you are not having too many crashes. Then crash risk control. If you can improve the safety, in that case also you reduce the risk of having a crash, or you can reduce the severity of that crash. So that is another way. And third one is injury control. When a crash happens, still the injury level is low. It can be done in many ways. Say, for example, you can make the highways infrastructures in such a way that if it hits something, the damage is not that high. I think you remember reading about the forgiving highway concept. Or you can make the vehicle in such a way that even if it sustains a crash, the damage is not that high. Or say, for example, there can be gears. Say, for example, someone riding a bicycle or motorbike, the helmet and the knee guard and other things. So you can use those things to actually control your injury. So these are part of injury control. So the Safer Roads, a guide to road safety engineering, according to them, they also have kept crash control. Then they have also kept injury control, but the crash risk control, they have divided it into two parts, and injury control, they have divided it into two parts. First one is controlling injury on site. Second one is post-injury management. So if someone is injured, how fast can you recover that person? How safely can you recover that person? And কোনটা? না না না, স্লাইড চেঞ্জ করতেছি না, এই স্লাইড নাম্বার 2 তেই এক্সপ্লেইন করতেছি। হ্যাঁ, so post injury management actually includes like going to the site fast, rescuing that person, bringing that person to hospital for proper treatment, and inside that ambulance giving treatment. So if you can improve these things, then also you can improve things. And injury control, I have already explained, like you can make highways more forgiving, the vehicles can be better, and the drivers can be equipped with better safety gadgets or gears. And now crash risk control, it is divided into two parts in Safe Roads guideline. One is crash prevention, like you want to prevent as many crashes as possible, and you modify the behavior of people, because like most of the times crashes happen because of the attitude of the people, behavior, knowledge about safety, reckless driving habits, drunk driving, or say like not following the rules, or not like using seat belt and other things. So behavior modification, they think, is also an important factor. So now the purpose of crash data collection. So first we have learned what are the two guidelines we follow to actually control or reduce the impact of crash. And now Second thing is, why do we need to collect crash data? We need to collect crash data to identify locations at which usually high number of crashes occur. We call them hotspots or black spots, and the places where we have a lot of crashes happening. Then if we don't have the data, then how can we understand whether a lot of crashes are happening in a place or not? And then we are saying a lot of crashes, but is it actually significantly more than the crashes happening in other parts of the network? So we will answer these questions as we move on in today's lecture. The second point is detailed functional evaluation of high crash location to determine contributing causes of crashes. So if we have data, crash data, we can identify, okay, many crashes are happening in these places. Second thing is, crash data also tells us why these crashes are happening. Why do we have, what are the contributing factors of these crashes? Third one is development of general statistics measures at various crash-related factors to give insight into general trends, common causal factors, drivers profile, and others. Say, for example, if number of crashes are increasing or decreasing, or does it have any relationship with some changes that we have made? What are the most common causes of crash? Then what kinds of drivers are most commonly involved in crashes or any other factors? Then development of procedures that allow the identification of hazards before large number of crashes occur. So whenever you find like, okay, these are the reasons why a lot of crashes happen. So when you design something new, you can actually take care of those issues so that your new design does not come up with the same things. Or you can check the design of the existing roads. We call it road safety auditing. And actually you can improve things. So these are the 4 reasons why we need to collect crash data. So do you understand why we collect crash data? And you also understand, I believe, the philosophy of the 2 guidelines. Now, how will you know that a crash has happened? And this is one of the most important questions. The first one is motorists' crash reports. So, if someone is traveling in the road and that person sees a crash happening, they can report it. Actually, for that, in our case, we have 999. If someone sees a crash, they can actually report it through 999. So field by each involved motorist in the road crash required for all crashes with injuries, fatalities, or property damage exceeding a prescribed limit. So like normally we expect that whenever someone will see a crash, that person herself or himself will report it. In our case, they can report it to 999. Another thing is when police gets notified, either through motorists or someone else calling, then police needs to go to the site and fill up a detailed form. In case of Bangladesh, we call it ARF, accident reporting form, and it has 54 pieces of information. So that's why like most of the time they don't really fill it up. So normally filled up by an attendant police officer for all crashes at which an officer is present. Whenever a police officer is present, if he sees a crash, that must be noted. Or if they get notified and they know that it is a fatal crash or serious injuries have taken place where emergency vehicles had to be sent or a lot of property got damaged, then police must go to those places and collect those reports. So do you now understand how crash gets reported and who collects the data? So data is always with the police in general. And a typical old days crash recording summary sheet will look like this. This is more like a summary sheet. So you have the location, the village, maybe this is a small area, and then you have the crash number or crash ID. On which date did the crash take place? And then here you have at what time did the crash take place? What are the vehicles that were involved? And here you have different codes. N means right turn. So this vehicle was taking right turn, the commercial vehicle was also taking right turn, and they collided. Accident type E. Accident type E means side swipe. So they hit from one side to another side. Then how was the weather condition? How was the road condition? How was the road surface condition? How many people got injured? How many people died? So all these information can be summarized this way. It's a very simple accident summary form. In our case, we have a big form with 54 variables. Now, we clearly understand that it cannot be something paper-based. These days, we have software in which we can keep this data. Say, for example, there are two very popular software for these things. One is called IMAP, and another one is called Driver. IMAP is a commercial off-the-shelf solution, COT. We call them COT. So you have to buy it from a company. So if you want to learn more, you can give search IMAP. It's made by TRL software. Okay, so I give them a lot of suggestions on how this software should be constructed. And actually, I am responsible for implementing IMAP in Dhaka Sylhet corridor for a project that IUT is doing. So I am directly and heavily involved in it. So this software Bangladesh government is buying to collect crash data on Dhaka Sylhet corridor. And Bangladesh government is planning to procure a crash data management system for the whole network within next 3 years. So then there is another one called Driver. So it is made by World Bank, and this software is actually free. It's like opening the PDF. Oh, okay, fine. Let's open the PDF. So GRSF money was taken from GRSF by World Bank to make this crash data management system. It is used in Bangladesh police is actually trying to use it in Dhaka city. And then Manila actually uses Driver, Brazil uses Drivers. There are some other countries which use Driver. So these days, crash data management system is very much computer based. And we keep the data in software. So statistical reports commonly generated from crash database are, so when you keep the data in the software, you can generate a lot of reports on the fly. Number of crashes by locations. So in which location, how many crashes have happened? Then type of crash. Was it a head-on collision? Was it a side swipe collision? Was it a tip-over collision? What is a single vehicle accident? So all these things you can write down under type of crash. Then type of vehicle. Was it a passenger car? Was it a bus? Driver characteristics. So who was the driver, whether he had a driving license or not, whether he was driving under any influence or not, then how many years of experience does he have, then time of day. So like, because from that you can understand like a lot of accidents happening in the morning or in the night time. Then weather condition, maybe we can see a lot of accidents happen during the first few days of the rainy season starting, or other stratification. Say a lot of crashes happening near this area, or when we have an event like this, something like that. Then crash rates by highway location and or segment. In how many crashes are happening in the intersection, how many crashes are happening in the basic freeway segment. Then again, driver characteristics, highway classification, whether we have many accidents in the national highway or regional highway or district roads, something like that, or any other variable. Correlation of types of crashes versus contributing factor. Maybe we have a lot of crashes involving say like illegal vehicles. So head-on collision, illegal vehicles. Side-swipe collision, maybe between two specific types of vehicles. Okay. So correlation of important projects with crash experience. So from that, say like if we have the crash database and we have improved some things in the road, and after that the crash database is suggesting that situation has improved or gone worse, so we can actually relate project with crashes. Like these kinds of projects will increase crashes, these kinds of projects will reduce crashes, something like that. And the types of statistics that we generate can be divided into three parts. One is crash occurrence, numbers and types of crashes that occur, which are often described in terms of rates. Say, for example, population or vehicle miles traveled. We'll look into this within a very few slides. Then crash involvement, number and types of vehicles or drivers involvement. And we can also represent it with population or various other kinds of indicators. Then crash severity. So one is crash occurrence, whether a crash has occurred or not. Second one is crash involvement, what type of crashes, what vehicles were involved, vehicles were involved, these kinds of things. And third one is severity, how many people died, how many people got seriously injured, things like this. Okay. Now, common types of crash analysis, the kinds of reports that we generate regularly. One is trend over time, whether the number of crashes are increasing or decreasing. Stratification by highway type and geometric element. Say, for example, divided highway, undivided highway. Then functional class, say, for example, national highway, regional highway, or like paved highway, unpaved highway. Stratification by driver characteristics, whether male or female drivers are having more crashes, what is this particular age group which is heavily involved in crashes. We can sometimes see like a lot of illegal drivers are there, or like old people having a lot of accident, or like very young people at the early ages of their driving, they are having a lot of accident. We can identify these trends and then we can do something about it. Stratification by contributing causes, like over speeding, vehicle defect, or the pavement condition not good. And then crash type, like a lot of head-on collision. So if you see a lot of head-on collision happening, then you will introduce you will introduce something called a barrier, median barrier. Okay. If you see a lot of crashes happening because of tip over, or say like because of like spilling over from one car, then you can actually like run off the road kind of accident. You can actually have guardrail kind of thing. And then you can have like stratification by environmental conditions. So for example, in winter, because of fog, a lot of accidents happening, or in the rainy season, heavy rain causes a lot of accident because the pavement becomes slippery, visibility becomes low. So you can come up with these trends and stratifications and try to improve the situation. Actually, there is something called IRAP, International Road Assessment Program. After your undergraduation, when your undergraduation is complete, you can actually go here, take a training and get accredited, and then you will get a certificate of IRAP. So for the next 1 year, you can actually rate the roads, whether this road is safe, whether this road is unsafe, and it's called star rating. 5-star road, 3-star road, 2-star road. Normally our target is to make all the roads at least 3-star. All the national highways at least 3-star. So there you can see, like if you change the weather condition, if you change the geometric condition, the crash risk increases or decreases for different roads. So up to now, do you have any questions from the first 7 slides? No questions? Okay. Then now you will be doing some mathematics, like calculating the crash rate. You can do the calculation based on 2 things. One is called population based, another one is called exposure based. Exposure based is always a better option because as much as you get exposed, your crash risk increases. If you stay for a long time on the road, then your crash risk will increase. If you travel a lot of kilometers, then your crash risk will increase. So this is exposure based. Population based is more like static. The area population, number of registered vehicle, number of licensed drivers, highway mileage. Even if you have a lot of registered vehicle, if people don't drive, actually, but still have a lot of accident, actually the rate will be low, but actually it's a very dangerous situation, right? If you have a lot of huge number of population like Bangladesh, but as we don't have a lot of roads or vehicles, we may not have a lot of accidents happening as compared to a developed country. So population wise, it will look small. But actually, if you see, we drive very little, we have very few roads, but still we have so many accidents. So population based will say it's not a serious case, but exposure based will say like actually it is serious. So that's why exposure based crash rates are more acceptable, but it is obviously harder to obtain. So population based rates, it can be fatalities, crashes, or involvements per 100,000 area population, or it can be based on 10,000 registered vehicle, or 10,000 licensed drivers, or 1,000 miles of highway. As these things are all static, it doesn't really change much every year. So we call them population based rates. Exposure based is like, say, like 100 million vehicle miles traveled, or 10 million vehicle hours traveled, or 1 million entering vehicle for intersections. So this is like purely you are relating the crashes with exposure, and these are actually better indicators. তোমাদের এই এক্সপোজার এইগুলা বুঝতে পারছো, ইন্ডিকেটর গুলা? কোনো কনফিউশন নাই তো? Okay. Then computing crash and fatality rates. So there is a small math problem. Normally these kinds of problems come every year. It's a small problem. So you have number of fatalities, number of fatal accidents. Can someone tell me what's the difference between fatalities and fatal accidents? কে বলতে পারবা?
স্যার ফেটালিটিস হচ্ছে অ্যাকচুয়ালি কতজন মারা গেছে, আর ফেটাল অ্যাক্সিডেন্ট হচ্ছে স্যার মানে যেটার মানে কেউ মারা যাওয়ার পসিবিলিটি আছে বা এরকম ম্যাগনিটিউডে কোনো একটা অ্যাক্সিডেন্ট গেছে।
না না না, ফ্যাটাল অ্যাক্সিডেন্ট মিন্স যে অ্যাক্সিডেন্টে একজন হলেও মারা গেছে, আর ফ্যাটালিটিস হলো গিয়ে ইন টোটাল কতজন মারা গেছে। সো ফ্যাটাল অ্যাক্সিডেন্ট 60 মানে হলো গিয়ে এখানে 60টা অ্যাক্সিডেন্ট হয়েছে যেখানে একজন হলেও মারা গেছে। সো ফ্যাটালিটিস উইল অলওয়েজ বি মোর দ্যান ফ্যাটাল অ্যাক্সিডেন্টস অর ইকুয়াল টু। আর 75 থেকে বোঝা যাচ্ছে যে কিছু কিছু অ্যাক্সিডেন্টে একজনের বেশি লোক মারা গেছে। Then injury accident means the accidents where someone got injured. PDO accidents means 2000 accidents happened where nobody got injured, but only property got damaged. And total involvement is like 4100. So total 4100 accidents happened. So you can see in some accidents, property damage was also insignificant. Now you have vehicle miles traveled, registered vehicle, licensed driver, area population. Now you can calculate the rates. Rates equal to the total that you have multiplied by scale divided by base. So here, rate 1, 75 people died. So 75 multiplied by 100,000 divided by 300,000 is equal to 25 deaths per 100,000 population. Then these are like population based. Then 7.5 death per 10,000 registered vehicle, or 5 deaths per 10,000 licensed driver, 5 deaths per 100 million vehicle miles traveled. So the fourth one is actually exposure based. Now you can also calculate something called severity index. Severity index is like 75 divided by 2360, because 75 people died and 2360 accidents had some kinds of severity, 2360. So 0.031 deaths per accident. That is the severity index. The accidents where they have involved some kind of severity was the rate of dying. So this is called severity index. বোঝা গেছে আমাদের?
স্যার সেভারিটি ইন্ডেক্সটা আমার একটু রিপিট করলে একটু।
সিভিয়ারিটি ইন্ডেক্সের উপরে থাকবে হলো গিয়ে কতজন লোক মারা গেছে, আর নিচে থাকবে কতগুলা অ্যাক্সিডেন্টে সাম কাইন্ড অফ সিভিয়ারিটি ওয়াজ ইনভলভড। ইন আওয়ার কেস এই যে এখানে মানে সিভিয়ারিটি ইনভলভ হওয়ার মতো কেস কতগুলা ছিল। প্রপার্টি ড্যামেজ হয়েছে 2000-এ, ইনজুরি হয়েছে 300টাতে, আর 60টাতে মানুষ মারা গেছে। সো দ্যাট ইজ দ্য টোটাল নাম্বার অফ ইনভলভড কেসেস, sorry, total number of cases where some kind of severity could have come. এই জন্য এটাকে নিচের এটা দিয়ে ভাগ করলাম, আমরা পেলাম। এখন বুঝা গেছে কিভাবে ক্যালকুলেশনটা করবা? সো আমরা নর্মালি স্ট্যাটিস্টিক্স দিয়ে বলি যে এখন যতগুলো রেট আছে এগুলো ক্যালকুলেট করো, রেট গুলো কম্পেয়ার করো, থিংস লাইক দ্যাট।
স্যার,
হ্যাঁ,
vehicle mile traveled এটা দ্বারা অ্যাকচুয়ালি কি বোঝায়?
তোমার মনে আছে ভেহিকল মাইল ট্রাভেল ক্যালকুলেশন আমরা যে করছিলাম
sir.
ভলিউম স্টাডিতে, যে
হ্যাঁ স্যার, আগেও ছিল।
হ্যাঁ, সো ভেহিকল মাইল ট্রাভেল দিয়ে বোঝায় যে আমাদের নেটওয়ার্কটা কি পরিমাণ ইউজ হয়। ধরো গাড়ি তোমার 1 কিলোমিটার রাস্তা আছে, একটা গাড়িও যায় না ওটা দিয়ে, তাহলে ভেহিকল মাইল ট্রাভেলড হলো 0। বা 1 কিলোমিটার রাস্তা আছে, দিনে একটা গাড়ি গেছে, তার মানে হলো গিয়ে 1 ভেহিকল মাল্টিপ্লাইড বাই 1 মাইল, 1 ভেহিকল মাইল। সো ভেহিকল মাইল ট্রাভেল যত বেশি হবে তার মানে এক্সপোজার তত বেশি, বুঝছো?
আর স্যার vehicle hours এর কেসে?
ভেহিকল আওয়ার্স কতক্ষণ লোকজন রাস্তায় গাড়ি রাখছে, কত ঘন্টা রাস্তায় গাড়ি ছিল। অনেক সময় দুইটাই লাগে কেন, অনেক সময় যেটা হয় যে তুমি ভেহিকল মাইলস ট্রাভেলড অনেক ছোট হইতে পারে কনজেস্টেড নেটওয়ার্কে, কিন্তু ভেহিকল আওয়ার্স ট্রাভেলড ক্যান বি ভেরি হাই। সে ফর এক্সাম্পল ঢাকা সিটি, তাই না? আমরা অনেক সময় রাস্তায় থাকি, সেই জন্য দুইটাই খুব ইম্পর্টেন্ট ইন্ডিকেটর।
জি স্যার, থ্যাংক ইউ।
Most welcome. Now, say these kinds of statistics we normally produce. You see here, you have the year here, and you have total number of deaths. You can see here, deaths per 1 million vehicle mile. So this is this block. You can see this is going this way. Deaths per 100,000 population. So this is like this. Vehicle mile traveled is like this. So you can clearly see. Can you tell me, this is American data? You have a drop here. Does it mean that situation is improving? What happened? Do you know what happened? কেন এটা নেমে গেল? কেউ বলতে পারবা? কি মনে হচ্ছে?
1945 স্যার।
হ্যাঁ,
Is this something related to World War
স্যার
II?
ওয়ার্ল্ড ওয়ারের কারণে।
হ্যাঁ, দিস ইজ ওয়ার্ল্ড ওয়ার। ওয়ার্ল্ড ওয়ারের কারণে যেটা হয়েছে, ওই সময় লোকজন যুদ্ধে চলে গেছে, তেল ছিল না, গাড়ি অত চলে নাই, সো এটা কমে গেছে। হ্যাঁ, দেন এগেইন এখানে দেখো যে 90s এর দিকে ইরাক ওয়ার, হ্যাঁ, অপারেশন ডেজার্ট স্টর্ম, সো এই সময় একটা ঝামেলা হয়েছে। কিন্তু দেখো থ্রু আউট দ্য টাইম তোমার কিন্তু গাড়ি চলাচল বেড়ে গেছে। সো এমনি এটা দেখলে মনে হয় যে এখনো তো প্রচুর লোক মারা যাচ্ছে, কিন্তু এই যে এটা দেখো ডেথ পার 1 মিলিয়ন ভেহিকল মাইল, এটা থেকে বোঝা যাচ্ছে যে আসলে কিন্তু মানুষ অনেক বেশি চলতেছে, এই জন্য অ্যাক্সিডেন্ট বেশি হচ্ছে, কিন্তু অ্যাকচুয়ালি আমরা এক্সপোজার বাড়লেও সেই অনুযায়ী মানুষ মারা যাচ্ছে না, তাই না? সো দ্যাটস ওয়াই উই নিড টু ক্যালকুলেট অল দিস ইন্ডিকেটরস, এবং এটাকে কারণগুলা, যেমন এখানে আমি কিছু একটা কাজ করছি সেটার কারণে ঠিক হয়ে গেছে, না হয়ে অন্য এক্সটার্নাল ফ্যাক্টরও হতে পারে। সো এগুলা ইন্টারপ্রেট কিভাবে করো স্ট্যাটিস্টিক্স, দ্যাট ইজ ভেরি ইম্পর্টেন্ট। Then normally, actually, if you get chance to visit one highway police station in Bangladesh, you will see they are supposed to have these kinds of maps as well. Like whenever there is an accident, so maybe the fatal ones are like motor vehicle versus pedestrian is this one. So motor vehicle pedestrian, motor vehicle pedestrian, motor vehicle pedestrian. Other motor vehicles are like this. Okay, and other traffic is like this. So other traffic, I think we don't really see any here. And when there is not a fatal crash, then they get marked like this way. So these are the identifying high risk crash locations. So you can clearly see this is one high risk crash location. This is one high risk crash location. This one, this one, this one. So if we have, or even this one is good. So you can say like, I have marked everything. I actually have not marked everything. See, 1, 2, 3, 4, oh, so many places. So we actually can identify the hotspots. So I'll be like going to this 1, 2, 3, 4, 5, 6, 6 sites and like seeing why these accidents are happening. Particularly this one, I definitely need to go. And this one as well, not this one, maybe this one is also very dangerous because lots of vehicle versus pedestrian. Okay, so something has to be improved throughout this corridor. We can clearly see. And now, how can you say like this location is high crash risk? Then again, the statistics comes. Okay, so you have to find a way to tell that this location is significantly more accident prone as compared to other parts of my network. And to do that, we do some statistical tests. What we do is we calculate the Z value here. You see, we calculate the Z value. X1 is actually accident rate at the location under consideration. So I'm saying this location has more crashes than others, significantly high. So with is it? So we calculate Xi, like how many accidents are happening in that location, minus X bar. How many accidents are happening in other 4-leg intersections? We can identify that. So that is like this, divided by the standard deviation of how many accidents happen in other 4-leg intersections. So then by getting that Z value, what we can say is the minimum crash rate considered to be significantly higher than the average may be taken as this. So we multiply 1.645 into that standard deviation plus the average, and if this one is actually smaller than this one, in that case X1 can be termed as high risk location. So you see here they have like in some location 15.8 crashes, average is like this, and this is the standard deviation. So we can see average plus standard deviation, it gives us this, but this one is actually bigger than this. So actually we cannot say that this location is very crash prone as compared to the other locations in this site. So you first identify the places which are more crash prone than average, and then you go into further detail about identifying why crashes are happening in those areas, and you can then do something about it. বুঝা গেছে এখন এই ক্যালকুলেশন গুলা? বুঝতে পারছো?
Yes, sir.
Good. Then another important thing that we can do is when we identify like, okay, these are the places where we have a lot of accidents, we can do some before after analysis. We can do something to improve that situation. Then say we give it a time, say for example 3 months, to get people adjusted to the new system, and then we again collect crash data. Maybe if the beginning crash data was for 3 months, the after crash data should also be for 3 months, and then we compare like whether the change that we can see is positive or negative, and whether it is significant or not. So to do that, we use a chart like this. So this is before after crash analysis. But if the number of crashes are too small, then we cannot have the normality approximation, and we have to use either Poisson distribution or binomial tests. So that's another area. Say for example here, we have seen like before the project, we had 10 accidents in that location. And after the project, we see 40% reduction in crashes. So you will go here and you will come here. And actually you should take this line extended and see where it cuts this decrease. So if this value is higher than this one, it means this change is not significant. If this value is lower, so here it is lower. So it means that although we can see 40% reduction in crashes, but we are not so happy. It is not a significant decrease. But if we would have come like 90% has decreased or 80%, then your point would have been somewhere here. So it's higher than this one. So you would have told like, okay, the change is actually significant. But one flaw with this method is it assumes that the crash reduction has been due to this project, but it can be for other reasons as well. So for example, there is COVID, nobody is driving, you will see a reduction. You have done nothing, but there is a reduction. So I have to relate it with the circumstances in that area. And normally what we do is we sometimes can have some control sites, like whether an intervention is working or not. Say we have introduced dividers and now we want to see if crashes are reducing or not. So if you have 10 sites where you think a lot of accidents are happening because of lack of dividers, you see a lot of head-on collision and something like that. So you can build, say, like divider in 8 or 9 places and leave 1 or 2 untreated, and then those are controlled where you have done nothing. So you have seen these kinds of accidents now, this number, and after some times you are thinking it will increase up to this. You have seen it in your project side, you have seen this projected is according to that is, but your actual is lower. So you can say like, okay, this solution has worked. But this is a controversial method because then we intentionally keep some sites untreated and let accidents happen. So these days, people are like very much against this idea of doing before after this way. And once, so do you have any questions? Any questions so far?
স্যার পেজ
হুম।
19 এ যদি একটু যাইতেন
হুম।
স্যার এখানে যে 10 মানে বিফোর কাউন্ট 10টা কিভাবে বুঝলেন এটা একটু
এটা আমরা একটা সাইট সম্পর্কে অনেক অভিযোগ পাইছি। আমরা 3 মাস ধরে ডাটা কালেক্ট করছি যে কতগুলো অ্যাক্সিডেন্ট হয়। আমরা দেখলাম 10টা অ্যাক্সিডেন্ট হয়েছে, ওকে ফাইন। তারপর আমরা এটার কারণ খুঁজে বের করলাম, এই কারণে অ্যাক্সিডেন্ট হয়। তারপর একটা প্রজেক্ট ডিজাইন করলাম, প্রজেক্ট ডিজাইন করে ওইখানে সলিউশনটা দিলাম। সলিউশনটা দেওয়ার পরে সপ্তাহখানেক ওয়েট করলাম, লোকজন অভ্যস্ত হয়ে গেল। তারপর আবার 3 মাস ধরে ডাটা কালেক্ট করছি, করে দেখলাম এবার 6টা অ্যাক্সিডেন্ট হয়েছে। তার মানে 40% রিডাকশন। বুঝে গেছে?
জি স্যার বুঝতে পেরেছি
So now, when you are sure that these are the locations where you have a lot of accidents and you have to do something about it, what do? You do site analysis. So how do you do that? Once a location of crash has been statistically identified as a high crash location, detailed information is required in 2 principal areas. One is like occurrence of crashes at the location in question, like what kind of crashes are happening, at what time they are happening, who are involved, what vehicles are involved, so everything. And then environmental and physical condition of the existing location. This is often done by reviewing all crash reports for a given location over a specified period. So you keep on reading the crash files from the police, and then you actually draw 2 diagrams. One is called collision diagram, another one is called condition diagrams. So collision diagrams can be drawn this way. You know, like passenger car, maybe you represent them as this. Truck, you represent them as this. Bus, you represent them as this. So these are the vehicle type symbol. This is accident type. This means rear end. This means head on. This means right angle. Okay. Then if you add this, it incorporates traffic movement. This is severity. Okay. And after that, you prepare diagram like this. And from that, you can see, like, say here you have some data. You can clearly see lots of accidents during night time. Lots of injury. Actually, fatality doesn't happen, but during daytime, people get more injured. Nighttime, mainly property damage only. So you can get some ideas about high nighttime crashes, or from here you can see like this is rear end, rear end, rear end. This is rear end. So rear end crashes are most common. So you can get an idea about what kinds of accidents are happening. Okay. And then you can also create something called condition diagram. You put the geometry, you could put the land use and everything. Now you try to relate a lot of these kinds of accidents happening at this time. The land use is like this. So why are those accidents happening? And then you start getting some ideas about the causes, and then you can design the interventions. And normally these diagrams cover around 0.25 to half miles. So this should be 0.25 to half miles in general. And then after you have the condition and collision diagram, you come up with these questions and answers. Objective is to find contributing causes to the observed crashes based on design, control, operation, and environment. Crashes are grouped by their types, and you ask yourself these questions. What driver actions lead to occurrence of such crashes? What existing conditions at the site could contribute to drivers taking such actions? What changes can be made to reduce chances of such crashes taking place? And then you can actually come up with solutions. So this is all regarding crash studies. Do you have any questions regarding this? কোনো প্রশ্ন আছে? ওকে, দেন আমরা আবার একটা ব্রেক নিব, ধরো 6-7 মিনিটের। 10টার থেকে আবার শুরু করে পার্কিং ধরবো। নেক্সট 30 মিনিটসে পার্কিং এর 50% আমাদের শেষ হয়ে যাবে। সো আজকে আমরা ডিলে পড়লাম, প্লাস ক্র্যাশ পড়লাম, এখন পড়বো পার্কিং। ওকে, জাস্ট টেক এ ব্রেক অফ।
বলেই তো আজকে ক্লাস শেষ না, আমাকে আরো
পার্কিং এর পরে আজকে ক্লাস শেষ হয়ে যাবে। পার্কিং এর ইনভেন্টরির একটা ব্যাপার আছে, ওইটা আরেকটু ঝামেলা করে পড়াইতে হবে, ইন্টারসেকশনের সাথে একসাথে পড়াবো। পার্কিং দিয়ে আজকের ক্লাস শেষ হয়ে যাবে আর কি, পার্কিং এর ডিমান্ড অ্যানালাইসিসটা পর্যন্ত করে। হ্যাঁ, সো টেক এ 5 মিনিটস ব্রেক এন্ড দেন উইল কাম ব্যাক এগেইন।
স্যার আসসালামু আলাইকুম।
আমরা এখন পার্কিং স্টাডি পড়ব। So this will be actually the last study that we are going to study in our course, and after that there will be only signal design left. So we have in a way finished the course as soon as we finish this study and the next topic. So the economic survival of most activity centers is directly related to parking and other forms of access. So you can understand, like, if you make a facility and you expect a lot of people to go there and there is no parking. So like a shopping complex like Jamuna Future Park or Bosundhara City, if there is no parking and if you are not allowed to park the vehicle near that area, actually how many people will actually go there, because we don't really have a good public transport system. So maybe the whole area will fail. Okay, so parking supply must be balanced with other forms of access, so like public transport, traffic condition created by such access, and the general environment of the activity center. And normally when you are talking about parking, you need to address four things. One is like parking generation and supply needs. Actually, we will learn this in today's lecture. Then parking studies and characteristics. So first we will learn about the relationships of parking with different land uses, and if we have a residential area, if we have a commercial area, how many parking spaces should be kept there. We'll learn about that in the parking generation and supply list. Then parking studies and characteristics. This gives you idea about the actual demand. One is theoretical, the first part, and second part is actually giving you theoretical, practical demand, like how many people are actually going there to park and how long are they keeping their vehicles parked. Third one is parking facility design and location. So where will you make the parking? Are you going to make everything parallel parking? So like this is the road, you can park this way, or it can be angular parking like this. Okay, or so this is perpendicular, this is angular, and this is parallel parking. So what kind of arrangement should be there? So all these things are in the parking facility design and location. And next is parking program. In the parking program, you come up with the parking charges, how long can you keep it parked, so things like that, all the laws and regulations. So you need these four things to actually complete your parking study. Now parking generation, normally there is a unit in which we represent parking generation. Single family residential, normally we use number of parkings per dwelling unit, or you can also make it per dwelling unit with range by number of bedrooms. This is the alternative unit. So same way as apartment, residential, shopping center, retail, office, say for example employee in industry, per employee or per 1000 square feet of gross floor area. Okay, bank, per 100 per 1000 square feet of gross feet area, or say for example bowling alley, per lane or per 1000 square feet of gross floor area. So these are the standard units that we use for different kinds of land use when we are talking about parking generation. Then typical parking generation rate. Results may vary significantly when separate calculations are made using average rate and the equation. So there are some equations as well, and there are some average rate as well. So you will see the results will vary. If you use average rate, the rate is something like this. If you use the equation, because they have more variables into it, maybe the number will vary. So for your location, it is important that you do some localized study and come up with the parking requirements. Actually, one of my students in master degree, she is working on parking demand based on land use and socio-economic aspect. An area which is not so rich, It has good public transport facilities, and the roads are very narrow. Maybe the parking demand will be lower than what it is in Gulshan corner plot next to a very big road. So, according to our law, both the places, if they are under Dhaka City Corporation, they have the same parking requirements when they build a structure, but it will actually vary. So my student is actually working on those things now, one of my master students. So it's more like a localized study. So here you see from different studies, we can come up with different rates. So like these are the rates and these are the equations. So you can see, like if you put the equation value for X is like number of dwelling units or something like that so you will see the value that this one and that one may not match. So that is what they were saying, that the rates and the equations may not give good results, same results. So for every city, in general, you have these equations and relationships developed. Bangladesh, we don't really have these kinds of well-structured parking guidelines. So here is a summary, like how many studies have suggested that this equation works or something like that. Okay, so but this is for actually developed countries. And very simple way of calculating parking demand. Sometimes you have charts like this, like for shopping centers, the center size is here, and then percent uses by movie house, restaurant, and other entertainment. So what percentage of this commercial building has movie house, restaurants, and other entertainment places? So like this. So what will be the number of parkings required in 100,000 square feet? So here you see area is this, so it's falling under this category, and 15% is occupied by entertainment, restaurant, theaters. So 15, so this is like this. So the parking demand will be this one multiplied by the total area divided by 1,000 square feet, because it's all in per 1,000 square feet. So you need actually more than 4,500 parking spaces for this shopping center. Then just like traffic on road, here also you have peak demand, and you have to design it for the peak hour. So the peak demand is NKRP multiplied by PR divided by O. So N is equal to size of activity measured in appropriate area, so the floor area. Then K is proportion of destinations that occur at any one time. So how many people at any one time would like to come here? R is the person destination per day. How many people are actually traveling to that area per day? And P is proportion of people arriving by car. So how many of those people are arriving by car? And PR is proportion of person with primary destination as designated study location, where their primary, they went out to come to this area. So this is this part. And O is the average auto occupancy. How many people are there in one car? Here, this is for the developed countries. So they don't consider the fact that in our countries, we actually have drivers. So in our case, it should be always -1 in most cases. And that's how you calculate the demand during the peak hour. And you should be able to facilitate the parking spaces requirements based on the peak demand. Otherwise, there will be a spillover on the road and it will create congestion, increasing other people's travel time. So here is a small, bolo.
স্যার পিআরটা কি আমরা একটু বলবেন?
PR হলো গিয়ে কতজন, ধরো 4টা জায়গায় যাবে, কিন্তু আসল উদ্দেশ্য ছিল এই জায়গায় আসা, এই জায়গায় এসে তারপর তারা বাকি কাজ করবে, মানে এইটা তাদের মূল উদ্দেশ্য ছিল আজকে ট্রাভেলের, এই জায়গায় আসা। মানে জিজ্ঞেস করলা যে আপনি কি আজকে এই জায়গায় আসার উদ্দেশ্যেই বের হয়েছেন, মানে এটাই কি আপনার মেইন উদ্দেশ্য ছিল এখানে আসা? তো সেটা এমন হতে পারে যে না, এটা মেইন উদ্দেশ্য ছিল না, আমি আশেপাশে যাচ্ছিলাম এই জন্য আসছি, তার মানে কি এই লোকটা রেগুলার আসবে না। হ্যাঁ, কতজন লোক রেগুলারলি এখানে আসে সেটা বোঝার জন্য শপিং কমপ্লেক্সে। বুঝা
জি
গেছে?
স্যার, হ্যাঁ বুঝা গেছে।
সো এখানে একটা ছোট্ট এক্সাম্পল আছে একটা CBD তে ওই যে 40% of all shoppers and CBD are for other reasons, তার মানে 60% এই রিজনেই আসছে। তো এইভাবে করে ওই যে PRP সবগুলো ক্যালকুলেট করে ওই যে ডিমান্ড বের করছে 1008টা পার্কিং স্পেস দরকার পড়বে আর কি। হ্যাঁ, সো there are some guidelines as well for offices. You should have 0.02 spaces per 1000 square feet, যেটা আমাদের জন্য অনেক লো হয়ে যায়। ব্যাংকের জন্য 1 to 2 spaces per bank minimum. Restaurant 0.3 per 1000 square feet. Retail shops less than 500,000 square feet is like this space. Retail shop over this is like this, but then there are some other requirements. Disability, there should be one for the disability. Didn't I put it there? আমি একটা ভ্যালু এখানে পুট করি নাই অ্যাকচুয়ালি। প্রত্যেকটা পার্কিং লটে একটা মিনিমাম নাম্বার অফ প্লেসেস রাখতে হয় ডিসেবল পিপলের জন্য। এটা নেক্সট ক্লাসে মনে করো, ওইটার গাইডলাইনটা এখানে দেওয়া হয় নাই, আমি ওটা কালেক্ট করে দিয়ে দিব। ও নো নো নো, সরি, দিস ইজ দ্য হ্যান্ডিক্যাপড ওয়ান। হ্যান্ডিক্যাপ, তাই তো বলি, হ্যান্ডিক্যাপেরটা দিব না কেন? প্রত্যেকটা ব্যাংকের জন্য যখন তুমি পার্কিং ডিজাইন করবা 1 থেকে 2টা গাড়ির স্পেস রাখতে হবে হ্যান্ডিক্যাপ পিপলের জন্য। হ্যাঁ, তারপর রিটেইল স্পেসের জন্য এই যে এত স্কোয়ার ফিটে, তার মানে 10,000 স্কোয়ার ফিট কি 1 লাখ স্কোয়ার ফিট হইলেই 6টা জায়গা রাখবা তুমি, যেখানে আর কি যারা ডিসেবলড পিপল, হ্যান্ডিক্যাপ পিপল তারা এখানে পার্ক করতে পারে। ওদের জন্য কিন্তু পার্কিং স্পেসটা একটু বড় হইতে হয়, like they have to open the door and sometimes they have to use switch to actually uh, their seat will actually come out and then they can access a wheelchair, something like that. So these are special places and this should be reserved. বুঝা গেছে? এটা হ্যান্ডিক্যাপ পিপলের জন্য মিনিমাম রিকোয়ারমেন্টস রাখতেই হবে তোমার। Then this is like say for example you are going to a shopping complex. How far are you willing to keep your car and then walk? In case of international trade fair, sometimes you will keep the car 1 kilometer away and then just walk, right? So here you see everybody wants to keep their vehicle at the location. If it is 0.05 miles away, 30% will say on an average, I don't wanna go there and park my vehicle like 0.05 miles away. 30% will say like, no, I don't want it. I don't want to walk for like 0.05 miles. And you will say, see, if people have to walk for 1 mile, nobody will like to park their vehicle 1 mile away. So why do you need this information? Because if you want to design a parking lot in abroad, actually parking lots are also commercial. You can have multi-storied parking lots. So you have to take care of the land use. If it is not very close to the land use, your demand will be low for that parking lot. So this is a relationship between walking and parking demand. Okay. So how far would you like to park your vehicle and walk to access a facility? So this is very important for us. And with this, we will actually end today. Next day, we will do some data collection study. And with that, we will end the parking study. And this will finish almost all the topics that we were supposed to cover in this course, except for signal. And the next 2 lectures will be on signal, and the final lecture will be on review. And our other faculty member who has already taken 1 lecture in the before midterm, he will take the final class, but it will be more like a review. But that is also on demand. If you need it to be more than 1 classes, he will arrange that one for you. তো তোমাদের কোনো প্রশ্ন আছে এখন পর্যন্ত?
স্যার আমাদের ফাইনাল এক্সামে কি মানে মিড টার্মের সিলেবাসটা কি থাকবে?
হ্যাঁ, আমাদের নিয়মই এটা, কম্প্রিহেন্সিভ এক্সাম। আর ওই আইইউটি তে আগে একবার বলছিল যে থাকবে না এসেই, কিন্তু এখন আর ওগুলা করতে পারতেছে না। আর বি শিওর ফাইনাল এক্সামও ফিজিক্যাল হবে। গতকালকেও আমাদের মিটিং যেটা হয়ে গেছে সেখানে যেটা বোঝা যাচ্ছে, যদি এরকম হরতাল অবরোধই থাকে, সব শুক্র শনি করে আমরা পরীক্ষা নিয়ে নিব। আমাদের তো জাস্ট 6টা দিন লাগে, তাই না? 6 দিন পরীক্ষা, 6 দিন 2 বেলা পরীক্ষা নিয়ে আমরা শেষ করে দিব। সো আর তোমরা যারা হলে থাকো, ইউ আর সাপোজ টু স্টে ইন হল। তোমরা হল থেকে বাসায় যাওয়ার কথা না এই টাইমে, বিকজ দিস ইজ নট এ ভেকেশন। আর তোমরা যারা বাইরে থাকো, শুক্র আর শনিবারে তো ট্রাভেলে কোনো প্রবলেম হবে না আশা করি ইনশাল্লাহ। সো বি 100% শিওর আমাদের ফিজিক্যাল এক্সাম হবে, এবার আর অনলাইন এক্সাম হবে না। হ্যাঁ, সো মেন্টালি ওইভাবেই প্রিপেয়ার হও। আর কুইজও আমার যে 2টা বাকি আছে, ও 2টাও ফিজিক্যালি হবে। ওই 2টাও অনলাইন হবে না, কোনো অ্যাসাইনমেন্ট দিয়ে রিপ্লেসমেন্ট হবে না। সো মেন্টালি ওগুলোর জন্য প্রিপেয়ার হয়ে থাকো। তো তোমাদের কি আর কোনো প্রশ্ন আছে?
স্যার আমাদের কুইজের সিলেবাসটা হচ্ছে স্যার কোন কোন উইকের, এটা আরেকবার একটু ক্লিয়ার করা যাবে?
হ্যাঁ, এইটা ইব্রাহিম বলে দিবে। ইব্রাহিমকে গতকালকে ইনস্ট্রাকশন দেওয়া হয়েছে, প্লিজ একটু ওর সাথে কথা বলে এটা ফাইনালাইজ করে নাও। মানে অল্প কিছু কাজ রাখা আছে ওর জন্য, সেটার মধ্যে এইটা একটা। হ্যাঁ, গতকালকেও আমি ওকে ক্লিয়ারলি ইনস্ট্রাকশন দিয়ে দিছি। সো যে কোনটার উপর এক্সাম হবে, কিভাবে হবে না হবে। সো একটু ওর সাথে কথা বলে ওকে বলো জিনিসটা আমাদের গুগল ক্লাসরুমে পোস্ট দিতে একটা, তাহলে আমিও জানলাম যে তোমরা এটা জানো।
ওকে
আর
স্যার।
সেকেন্ড আরেকটা জিনিস যেটা, সেটা হলো ইটা, ওই যে তোমাদের পরীক্ষার নাম্বার, ওইটা অবশ্যই আমাকে কথা দিচ্ছে যে আগামী উইকের মধ্যে ডিস্ট্রিবিউট করে দেওয়া হবে আর কি। মানে কিছু কিছু জায়গা নিয়ে আমরা একটু ছিলাম, যেমন ওর সাথে আমার কয়েকটা জায়গায় আর কি একটু ছিল, যেমন ও ডায়াগ্রামে বেশি মার্ক রাখতে চায় না, আমি ডায়াগ্রামে বেশি মার্ক রাখি, পরে আমি ওরটাই মেনে নিছি। কারণ ও যেটা বলে যে স্টুডেন্টরা লাস্টলি ডায়াগ্রামে এসেই ভুল করে, ওটার উপর বেশি মার্ক রাখলে নাম্বার কম উঠবে। আমরা ওকে ফাইন, নাম্বার তো কম দেওয়া আমার উদ্দেশ্য না। সো অনেক লিনিয়েন্ট গ্রেডিং হয়েছে এবার আর কি, অনেক অনেক লিনিয়েন্ট গ্রেডিং। পুরাটা আমার কন্ট্রোল থাকলে এতখানি লিনিয়েন্ট গ্রেডিং হইতো না। সো ওই জন্য আর কি একটু টাইম লাগতেছে। ওর সাথে আমার ওইখানে একটা কনফ্লিক্ট ছিল, আমি চাচ্ছিলাম সববার যেভাবে করি সেভাবে, ও চাচ্ছে আর একটু লিনিয়েন্ট, হুইচ ইজ গুড। ভালোই হয়েছে এটাতে তোমাদের জন্য। তো এনি মোর কোয়েশ্চেন্স? ওকে ফাইন, তাহলে আমাদের আজকের লেকচার এখানেই শেষ। নেক্সট উইকে ইনশাল্লাহ আবার দেখা হবে তাহলে। ওকে, তাহলে আল্লাহ হাফিজ।
আসসালামু আলাইকুম।
ওয়ালাইকুম আসসালাম।